Arithmetic. Arithmetic is the math we all learned first: adding, subtracting, multiplying, and dividing. The word arithmetic comes from the Greek arithmos, meaning number. That's right, it literally means the science of numbers. It's been around for thousands of years. Ancient civilizations like the Babylonians and Egyptians used it as early as 2000 BC for trade, construction, and even keeping time. And here's the cool part. Arithmetic is the foundation of all math. Without it, we couldn't handle money, cook recipes, or even tell time. So the next time you solve 2 plus 2, remember, you're using a skill that humans have relied on for over 4,000 years. Algebra. Algebra is the next big step after basic math, and it's where numbers meet letters. Instead of just solving 2 plus 2, algebra lets us solve things like x plus 2 equals 5. Now you're thinking logically, solving puzzles, and unlocking patterns. The word algebra comes from the Arabic word al-jabr, which means reunion of broken parts. It was first developed in the 9th century by a Persian mathematician named Al-Khwarizmi. Yep, the guy whose name gave us the word algorithm. Algebra includes everything from simple equations in pre-algebra to more advanced things like polynomials, functions, and graphs. Why is it important? Because algebra is the language of science, engineering, computers, even economics. It's the gateway to higher-level math. So when you solve for x, you're not just doing homework. You're training your brain to think logically, solve problems, and see the hidden structure of the world. Geometry. Geometry is the math of shapes, space, and how things fit together. From triangles and circles to angles and lines, geometry is everywhere, in architecture, art, design, and even nature. The word geometry comes from the Greek geo, meaning earth, and metron, meaning measure, so it literally means measuring the earth. It started with the ancient Egyptians and Greeks, who used it for building pyramids and mapping land. One of the most famous books in math history, Euclid's Elements, was all about geometry and written over 2,000 years ago. In geometry, you learn how to calculate area, volume, and prove theorems, like the legendary Pythagorean theorem. Why is it cool? Because it helps you see how the world is built, from city layouts to space travel. So next time you see a perfect circle or a sharp triangle, remember, that's geometry at work. Trigonometry. Trigonometry is the math of angles and triangles, especially right triangles. At its core, trigonometry is all about the relationships between sides and angles. You'll meet functions like sine, cosine, and tangent. Strange names, but super powerful tools. The word trigonometry comes from the Greek words trigonon, meaning triangle, and metron, meaning measure, so it literally means measuring triangles. It started with ancient Greek astronomers and Indian mathematicians who used it to study the stars and track time. Today, trigonometry is used in engineering, architecture, physics, video game design, and even GPS systems. It builds on geometry, but adds a layer of abstraction, like ratios, unit circles, and wave patterns. Sounds tricky? It can be. But it's also fascinating once you see how it all connects. So the next time you look at a triangle or measure an angle, you're thinking like an ancient astronomer, using trigonometry. Statistics and probability. Statistics and probability is the math of data, chances, and predictions, and it shows up in real life more than you think. Statistics helps us understand data, like averages, trends, and patterns. Probability is all about chances, like flipping coins, rolling dice, or wondering if your friend will finally show up on time. The word statistics comes from the Latin status, meaning state, because it was first used to study populations and governments. Probability actually started with gamblers trying to win more. Yep, some of the earliest probability math came from people who really didn't want to lose their gold coins. Still today, probability is used in games, betting, and casinos. Just remember, if you're betting against your child tuition fees, you might want to double-check your math. Beyond games, stats, and probability help power science, medicine, sports, and even your social media feed. It may seem simple at first, but interpreting real-world data can feel like guessing the next card in a rigged deck. So next time someone says, there's a 70% chance of rain, remember, you're hearing math in action, not a lucky guess. Linear algebra. Linear algebra is the math of vectors, matrices, and systems of equations, or as some say, the secret language of computers and physics. At first, it feels simple, solving equations with multiple variables. But then it takes a twist. You start dealing with rows and columns of numbers called matrices, and suddenly you're rotating objects, transforming spaces, and solving problems in multiple dimensions. The word linear comes from working with straight lines and algebra. Well, you already met that guy earlier. Linear algebra is everywhere. In graphics, AI, machine learning, 3D animations, and even Google search. Yes, vectors help decide what results you see online. It starts easy, but concepts like eigenvalues, eigenvectors, and vector spaces can feel like a brain workout, or like trying to fold a fitted sheet. But stick with it. Once it clicks, you're literally thinking in higher dimensions. So next time you see a 3D model, a video game character move, or a robot navigate a room, there's a good chance linear algebra made it possible. Calculus. Calculus is the math of change, motion, and infinity. The ultimate tool for understanding how things shift over time. Calculus is split into two main parts: differential calculus, how things change, and integral calculus, how things add up. Think slopes and speed or areas under curves. It's like zooming in and out on reality. The word calculus means pebble in Latin, because pebbles were once used for counting. But don't be fooled, this isn't child's play. Invented in the 1600s by Isaac Newton and Gottfried Leibniz, calculus helped explain gravity, motion, and planetary orbits. Today, it's used in engineering, physics, economics, biology, and even video game physics engines. What makes it tricky? It introduces wild ideas like limits, infinity, and instantaneous change, concepts that stretch your brain in new ways. But once you get it, it's like unlocking the code behind everything that moves, grows, or flows. So next time you hear about rocket trajectories, population models, or stock trends, you're hearing the power of calculus in action. Discrete mathematics. Discrete mathematics is the math of distinct objects, the ultimate tool for understanding patterns, logic, and counting in a digital world. It covers things like logic, set theory, graphs, and combinatorics. Basically how things connect, combine, and relate without the smooth flow of calculus. The word discrete means separate or distinct, because here, everything comes in clear, countable pieces, like building blocks. Though it sounds new, discrete math has roots going back centuries, but really took off in the 20th century with the rise of computers and algorithms. Today, it's the foundation of computer science, cryptography, network design, and much of modern technology. What makes it tricky? It dives into abstract concepts that don't always feel intuitive, like proofs with logic statements or counting possibilities in huge sets. But once you master it, you're basically fluent in the language of computers, codes, and networks. So next time you use your phone, browse the internet, or solve a puzzle, you're seeing discrete math in action. Number theory. Number theory is the math of whole numbers, the deep study of integers, primes, and the secrets hidden within simple counting. It asks questions like, what makes a number prime? How can we break a number into factors? Are there patterns in the digits we use every day? The Greeks called it higher arithmetic, and for centuries it was pursued purely out of curiosity, no practical use in sight. But surprise! Today, number theory is the backbone of modern cryptography, cybersecurity, and secure digital communication. What makes it tricky? It starts off feeling easy, just playing with numbers. But the deeper you go, the more abstract and puzzling it becomes. Simple questions can lead to problems no one has solved in hundreds of years. Think, unsolved mysteries, modular arithmetic, and reasoning that feels more like solving riddles than crunching numbers. But once you tap into it, it's like entering the hidden dimension of numbers, where even the simplest digits hold profound truths. So next time you type a password, encrypt a message, or hear about prime numbers, number theory is working quietly behind the scenes. Abstract algebra and advanced math. This is the most advanced level of math, where we stop working with regular numbers and start thinking about how math itself works. Abstract algebra studies rules, like how things combine or change, using systems called groups and fields. Topology looks at shapes and space. And yes, in topology, a donut and a coffee cup are basically the same. These subjects sound strange, but they help us understand patterns, symmetry, and the structure behind all math. They started in the 1700s and 1800s with smart thinkers like Galois and Noether, who wanted to explore deep math ideas. It's hard because it's very abstract. Less numbers, more logic and imagination, but once you get it, you unlock the secret code behind computers, physics, and even the universe. This is math at its deepest level, and it powers the future. If you finished watching, pay me back by liking and smash that subscribe button.